Hi, Natalie. Hi, Gabriella. You went to a petting zoo. Brenna, it is Velvet's birthday. Everybody say happy birthday to Velvet. You made an impulse purchase. I made an impulse, well, I bought a coffee machine yesterday and I'm really looking forward to getting it. So that was my excitement of the week. Anybody like travel out of town, gaming? That's awesome. You went to Arkansas. That's awesome. Arkansas is beautiful. I went to like what is it called? Like the Galveston area. It's called something else like Crystal Beach is where I went, I think. It was really fun. Hi Hannah. You saw the Batman. Who else saw the Batman? No spoilers. What did you guys think? Morning, Alexis. Anybody else saw the Batman? Yeah. Yeah, it was really good, in my opinion. But it was a little bit like dark. I don't know. Like literally, what irritates me in Batman movies is that it's always dark, like dim. The lighting literally, like not even the movie, but the lighting is always dim on purpose. It's like part of the cinema of it is. So even if they're like in direct sunlight, the direct sunlight looks dark and it really irritates me. Like I can't look at it. It's like you're wearing sunglasses while you're watching the movie. Yeah. Yeah, that's the theme of Gotham for sure. Yeah. Hi, Lainey. Okay, so if you haven't answered what you did over spring break, then go ahead and let me know. You can type it out. And then I wanted to know, okay, so the first question was let me send the slides. I forgot to do that. Here are the slides for today. You can join those. I love that I'm seeing some of y'all's faces. It's awesome. Okay. Okay, so what did you do over spring break? And then the second question kind of has to do with that. Hold on, is it gonna let me switch it? Okay, what would you do if you had a week off right now? So like looking back on how you spent spring break, what would you do differently or what would you do if you had another week off right now? Is there anything different that you do that you're like, oh, I wish I had done this last week? More homework, go see your friends, go see the bestie, go somewhere, no regrets. Catch up on school, go traveling, go to the beach. Yes. Love it. Okay. All right. So what is that everything here? Everybody has the slides, right? Let me send it one more time. I have a couple of memes for you guys because today we're going to talk about redox reactions. So first one, I think I've lost an electron. In fact, I'm positive. Get it? Isn't that funny? Okay. If I can't hear people laugh, then it's like I'm just staring at you guys. Okay, thank you, Josh. I appreciate that. I appreciate. Okay. Okay, the next one. I got one more meme. Wow, the prices have been reduced. And look at the equation that's there for the prices being reduced, which is not a really great time because right now the prices of everything are being oxidized right now. They're going up, right? I should have done one about oxidation, but that's pretty funny, huh? Okay, and on that note, you can tell that we're going to talk about oxidation reduction reactions. So by the end of this lesson, you should be able to recognize a redox reaction and explain what they are. You should be able to write redox hack reactions. And let's see, you should be able to predict whether or not a redox reaction should occur by the end of this lesson. And I will help you guys through that. So a redox reaction in general is something that happens when one atom experiences an increase in oxidation state, while another atom experiences a decrease in oxidation state. And the good news in this is that there is not any math in this concept for the most part. You just kind of have to understand how it works, and you do probably have to have a piece of paper to write down the equation, but there is no math. So what is oxidation state? That's the question, because we're talking about that. What's an increase in oxidation state and a decrease in oxidation state? So the atom that has an increase in oxidation state would say it's been oxidized because it loses electrons. And the atom that has a decrease in oxidation state is reduced because it gains electrons. Okay, so when you lose electrons, you get oxidized. And when you gain electrons, you get reduced. And so this is an acronym that I learned in college. It's called oil rig. Oxidation is losing, reduction is gaining. So it's in terms of electrons. So oxidation is losing electrons and reduction is gaining electrons. And you can remember that by the acronym oil rig. So pop question, if an atom gains an electron, it becomes more blank. I like the mnemonic there. Oh, cool, Brennan, you've already used that mnemonic device. It's so cool. Okay, if an atom gains an electron, it becomes more blank, negative or positive. We got 3 negatives. Any others? Great job. Okay, so it's kind of weird when you think about electrons. So the reason I do this pop question is because when you think about gaining something, if I said that I gain something, you think, oh, that's more positive, right? But with electrons, it's opposite because electrons are negatively charged. So if I gain an electron, I become more negative. So think of electrons like debt, like financial debt. If you gain debt, you become more negative, like your finances become more negative, right? So if you lose debt, you become more positive. And if you lose an electron, you become more positive. So that's kind of how electrons work. And I wanted to make sure we got that because it can be easy to be confused. So this is basically, look at this picture. This is what a redox reaction is. So we have 2 substances here, substance A and substance B, and both of them are in their neutral state. Okay, and then some reaction happens, okay, and then A now has a positive charge and B has a negative charge. So when you become more positive, it's called oxidation. So see how A went from 0 to plus, so it became more positive. And B went from 0 to -1, so B became more negative. So when you gain, when you become more positive, you're oxidized. And when you become more negative, you're reduced. So another way to look at that is right here. If you become more negative or more positive, another way of saying it is that if you're reduced, you gained an electron. And if you're oxidized, you lost an electron. That's the same thing between what those 2 things right there. These are the same way of saying it. So that's what a redox reaction is. So let's look at this real example here, or a more realistic example. Zinc plus copper with a +2 charge turns to zinc with a +2 charge and copper with a charge of 0. So which substance do you guys think was oxidized here? Zinc or copper? Which one looks like it was oxidized? I see a few coppers. Let's go back real quick. Oxidation means that you become more positive. So going from 0 to +1. So which one became more positive? Zinc, right? Okay, so zinc became more positive, and then copper, look how the copper became more negative, so it was reduced. So zinc became more positive, it was oxidized, copper became more negative, so it was reduced. Does that kind of make sense? In other words, zinc lost electrons and copper gained electrons. Okay, so here are some rules, some ground rules for how you look at oxidation state. The oxidation state of a pure element is always 0. So here's some examples here. Sodium, just by itself, has an oxidation state of 0. Chlorine has an oxidation state of 0. Even though there's a 2 there, it's just pure chlorine by itself. These aren't like bonded together. And so it has a state of 0. Hydrogen, copper, fluorine, those are all examples of things that would have a state of 0. So you would just write 0 about it for their oxidation state. But if you have like a compound, like, for example, look at the NaCl right here. If you have like a compound like that, it's not going to be 0 for each of them individually. So if you have a compound, the oxidation state of each atom is the same as its charge found on the periodic table. So you're going to need to use this. You'll come back to this. You can take a screenshot of it if you want, or you can just look at it in the slides. Again, here is the link to the slides if you joined a little bit late. but we're going to use this throughout this section here. So let's look at an example with, so follow this Jamboard link and we will move over and do an example of this. Let's see, right here. So there's a Jamboard link in those slides if you want to follow along. And we're going to do an example of this. So we have NaCl right here, right? And so because they're not by themselves, meaning they're bonded together, it's not like it's Na plus Cl. NaCl indicates that they're actually bonded together. We have to look up their charges. So when I look here, the charge for Na, you see Na right here, it's +1. And the charge for Cl, you can see right here, is -1. So do you see how I'm looking up those charges here? So this would be +1 and -1 for chlorine. I mean, for the sodium chloride. Now let's try for MgS. So I'm going to go look up Mg right here, and then S right here, and I'm seeing that they have a +2 and a -2 charge for the MgS. So +2, -2. Now let's try it for the Li3M, the lithium nitride. So I'm going to find Li, hold on. I'm going to find Li right here. It has a +1 charge, and I'm going to find N right here. It has a -3 charge. Thank you, Jade, for sending that link. So lithium is +1 and nitrogen is -3. So +1, -3. So if you notice with the first two, do you see how the charges cancel out to 0? They come out to 0 for those. Okay, let's look at this one. Actually, look at how many lithiums we have. We have 3 sets of lithium, and each lithium has a +1 charge, right? And then we only have 1 nitrogen, but that 1 nitrogen has a -3 charge. So hopefully you can see how this one also comes to a charge of 0. And in fact, all ionic compounds are going to cancel out to have an overall charge of 0. So it's kind of this neat way that ionic compounds work. So they're going to cancel out and get to 0. And if they don't, then you've probably done something wrong. So please ask a question. Does that kind of make sense on how you find those charges? Because you're going to need to do this when you're doing these types of problems. That kind of making sense? Awesome. Let me share this tab. Okay. So the next thing is that the sum of all the oxidation numbers is equal to 0 if the compound is neutral. So that's just what I talked about earlier. The sum of them is going to be equal to 0. Unless we have a situation like this, like NH4 or SO4, where it indicates a charge. Do you see how it indicates a charge there, plus and -2? So in that case, in that instance, it would not be equal to 0. So what would happen here, if we look up H, let's look at the NH4. If we look up H has a charge of +1, has a charge of +1. And there are 4 H's. So really, there's 4 of these. So it has a charge of +4. And we know that for sure. And then nitrogen, when we look here, look what nitrogen has. Nitrogen has a charge of -3, right? -3. So what is -3 plus 4? That's +1, which is what the charge is right there. So when it shows a charge, it will come out to being that charge. But other than that, it's going to come out to 0 if it doesn't show a charge above it. Okay. The next thing here, now we're actually going to practice. Okay. So let's look at this example right here. And I have got it pulled up on my Jamboard right here. So it says identify the substance being oxidized, reduced, and then this new thing that we're going to talk about. So let's look at their charges. So earlier we said when an element is by itself, its charge is 0. So what charge do you think the sodium has? What charge do y'all think? Zero. Great job. Sodium is by itself. There's 2 of them, but they're both 0, right? What do y'all think about the chlorine? 0 as well, because it's by itself. It's not bonded to anything else except itself. So its charge is 0. Now for this guy, these are 2 things bonded together. And so their charge is not going to be 0. We have to look it up on the periodic table. We have to look up sodium and we have to look up chlorine. So we're going to find sodium right here. and we're going to find chlorine right here. And sodium's charge is +1, chlorine's charge is -1. So +1, -1. Does that make sense? And how we look that up? See, this isn't too bad, right? It's not too bad. Okay, so now which one is being oxidized? Which one is being oxidized? Meaning which one is gaining, is losing an electron? Which one is becoming more positive? The sodium or the chlorine? Which one's becoming more positive? Na, great job. Which one is being reduced? Which one is becoming more negative? Chlorine, right? Cl. Okay, so that's all that there is to it, okay? Now it says identify the oxidizing agent and the reducing agent. This part is not hard either, so it's not like a whole new step. The thing that is oxidized is the reducing agent. The thing that is oxidized is the reducing agent. And the thing that is reduced, guess what? It's the oxidizing agent. Okay? So it really helps to write it down, otherwise you can confuse yourself. So the thing that becomes more positive is oxidized. And the thing that becomes more negative is reduced. And then whenever you tack the word agent onto it, you flip it. So something that's oxidized is the reducing agent, and something that's reduced is the oxidizing agent. Does that kind of make sense? Not too bad, right? Okay, love it. Thank y'all for interacting with me. Okay, so let's look at this one now. Identify the substance being oxidized, reduced for this one. So right off the bat, do you see how copper is by itself, the Cu? So I know that, okay, this is going to be 0, so that's easy. And then Ag over here is by itself, so it's going to be 0, right? So the only ones that I need to figure out are these two. So I'm going to go back to my periodic table, and I'm going to find Ag, okay? And Ag is right here. So Ag always has a charge of +1, okay? So I'm going to go ahead and write that. And then let me look at copper here, okay, on the periodic table. See how copper is not here? Copper is like somewhere over here. I don't remember exactly where it is. I think it might be right here, but I could be wrong on that. Copper is somewhere here where there's not a set charge. The charges in blue, the charges can vary, meaning there can be, it has different options for what it can be. So the way that we figure it out is we kind of go backwards. So NO3 is what we call a polyatomic ion. And I need to share a list of those, a polyatomic ion. But polyatomic ions always have a set charge. So for example, if you want to look it up, you could say, what is the charge of NO3? And the answer is -1. NO3 kind of works together here. So it's kind of an exception because it's kind of grouped together. So NO3 by itself has a -1 charge. So we're going to write -1 here, -1. And then if you notice, we have two sets of them. We have two NO3s. So the charge of copper is going to be +2. Does that kind of make sense for that? So which one's being oxidized? Which one is being oxidized? Which one is becoming more positive? Look at all we have the example. We can either choose this one, or this one. Which one's becoming more positive? The copper, right? The copper is becoming more positive. It's going from 0 to +2. Which one is being reduced? Which one is becoming more negative? The silver, right? The Ag, the silver. And then the NO3 is just a spectator. It's just there to hang out. It doesn't change at all, right? It's still the same on both sides. So NO3, we call that a spectator ion, meaning it's not really the spotlight of this interaction. It's not going to change at all. So we figured out that. And so which one is the reducing agent? Which one is the reducing agent? Great job. Copper is the reducing agent because you just flip it. Which one is the oxidizing agent? Great job. This kind of making sense for that? It's not too bad, right? So we're gonna look at one more concept. Let's see, we're gonna skip that one and we're gonna go to slide 10. So you're gonna have some situations. Let me talk about it here. where you have to predict whether a reaction will happen, okay? And what I have here is the key for it, okay? And you don't really have to memorize it as long as you write it down. So for the reaction to happen, the oxidizing agent must be above the reducing agent. So looking at our past examples, like I'm just copying over, remember on the sodium chloride, we figured out already which one was which. The sodium was the reducing agent and the chlorine was the oxidizing agent, right? So sodium is the reducing agent, chlorine is the oxidizing agent. When you figure that out, you find them on these columns. So let's find the oxidizing agent, which is chlorine. So let's see here. This is in your, this is table B18 in your chemistry reference guide. So see chlorine right here? That's chlorine. And then let's find sodium. Sodium is all the way down here. So for the reaction to happen, the oxidizing agent, see this has the columns there, right? The oxidizing agent, chlorine, must be above the reducing agent. So you guys tell me, that will this reaction happen? What do you think? Yes or no? Is the oxidizing agent above the reducing agent? Are y'all a little confused? I'm not seeing any responses. Normally y'all are super quick and speedy. Okay, so if the oxidizing agent is above the reducing agent, chlorine is our oxidizing agent and it's up here, and sodium is all the way down here. So yes, our oxidizing agent is above our reducing agent. Great job, guys. So it will happen. The reaction will happen, and that's our answer. Okay. Yeah, I know it's kind of some processing time there. Okay, so now let's try it with the silver here. Okay, so for the reaction to happen, again, the oxidizing agent must be above the reducing agent. And earlier, remember, we had this information here, +2, -1, and there were 2 of them, and then 0. So remember that copper was oxidized, so it's the reducing agent, and silver was reduced, so it's the oxidizing agent, the Ag with a +1 charge. Okay, so we have to find them here, and we have to figure out the oxidizing agent needs to be above the reducing agent. Okay, so we have to find the oxidizing agent, which is silver here. Is silver on here? Yeah. So I see silver right here. You guys see that? Ag plus. And then the reducing agent is copper, which is right here. So again, silver is above the copper. So yes, the reaction will happen. Okay, the reaction will happen. So again, if it's below it, we didn't do an example like that, but let's say that it was chromium down here, and then we had copper, then no, the reaction won't happen because it's below it. So you have to choose, like, you have to just decide, okay, is the column on the left, is it above or below the column on the one on the right? Does that kind of make sense? And that's how you predict whether the reaction will happen or not. Okay, y'all are doing great. So we're gonna pop back over to the slides here. I think we're done with the Jamboard. And all that I've got left for you guys is a learning check. So I want y'all to think through this yourself. Don't look at the chat until you've thought about it yourself, because I want everybody to kind of stop and see if you can activate this. So you may need to go back to the slides for a second. Identify each of their oxidation states, the K and the O. KO2. Ooh, I should have done, that's supposed to be K2O. I'm sorry. It should be K2O. Let me fix that. Not KO2. Okay, identify the oxidation state of K2O. Okay, Brenda already said, well, it's not 0. Okay, that's exactly right. So don't look at the chat. Think about it for yourself for a second. And then when you're ready, respond. But don't look at it until you're ready to respond. I want to see what y'all think. So identify K and identify O. So you may need to go back to the slides of the periodic table. So what is the oxidation state of K and what is the oxidation state of O? The total should be 0. The total should be 0. But look at each individual one. I want to see each individual one. Great job, Velvet. And then Ellie, Josh, Elizabeth, you guys are right that the total state is 0, like when you add them all together. But what are their individual states when you look at each one? Okay, great. I love, Josh, how you broke that down and you broke down the K into both of them. Great job. Anybody else need a little more time? I guess you can't type because you can't look if you need more time. Great job, Ellie. Great job. Any questions on this? Okay, remember, when you are getting oxidized, pop question, when you're getting oxidized, are you becoming more positive or more negative when you're getting oxidized? Okay, great job. When you're getting oxidized, you're becoming more positive. And when you're getting reduced, you're becoming more negative. Okay, when you're getting oxidized, you're becoming more positive. Are you gaining electrons or losing electrons when you become more positive? Remember oil rig? Losing, great job. Oxidation is losing, reduction is gaining. Oxidation is becoming more positive, reduction is becoming more negative overall, right? Great job. Okay, last thing, are there any questions that you guys have? Go ahead and put them in there if you guys have questions. And then I really want to show you guys this information. So if you're not here yet, that's totally fine. But when you get here, I made Unit 8 has like multiple parts that are difficult to understand. And so I made tutorial videos over each like section. So if you come and join my classroom, you'll be hearing kind of a repeat of that same video. So if you'd rather try the video first on your own before coming to my classroom, you're totally welcome to do that. And then Unit 8 resource document right here has like all sorts of resources in them. And then remember, I'm in my classroom all day if you guys need help with anything. So if you guys don't have any other questions, you're totally welcome to go. And then I'm going to answer some questions. Oh, that's a good question. Bella said, do the cars in the movie Cars have car insurance or health insurance? That's a great question. I guess car insurance would be health insurance. Any other questions? Hope you'll have a great day. Thank you so much, Brenda. Have a great day. Thank you, Ellie. Love the participation. Have a great day. Bye, Josh. Bye, Ari. Bye, Jade. Bye, Shannon. Bye, Velvet. Bye, Christopher. Bye, Mark. Bye, Alexis. Bye, y'all. I feel like I'm getting annoying now. Yeah, that'd be weird, Julia, to call it human insurance. But you can get pet insurance these days, so maybe it'll become more normal to call it human insurance. All right, any other questions that y'all have?